Okay. Okay, guys. It's time to show off where the game is at since last time. There have been a lot of changes to the code base, including a lot of new features and details. One of the biggest changes is that I'm now using CMake for the build system. This was an interesting learning experience, and I'm thankful to kind of understand how to slap things together now. The reason I did this is I easily wanted to integrate JSON parsing support into the game engine. Normally, doing something like this in a language like Python is trivial. However, since this is C++, we have a million different ways to parse JSON. And because I'm writing a game engine and not a JSON parser, I decided to use one of the most popular JSON parsing libraries, RapidJSON. This has ended up being a good decision, as RapidJSON is pretty easy to use, but one problem that resulted is that because I want to use C++ 17 features, I get a warning on my load.cpp file now complaining that standard iterator is deprecated. And because I normally prefer to compile with -w error on, unless I turn that flag off, my game won't build at all, lol. However, rather than try to convert over to a C++ 17 compliant JSON parser, I'll just deal with this inconvenience for now. Why all this trouble for a JSON parser, you ask? Because we want to start fine-tuning the game without having to rebuild it every time we want to change a variable. Wouldn't it be nice if we could just load in certain values from a file before the game actually runs and have the game actually use those values and have any changes made reflected on subsequent game runs? Hell yes, it would be nice. So that's exactly what I did. We're currently beginning the process of loading in configurations from file. Currently, we have two config files, game.json and textures.json. If we take a look inside game.json, we'll see a handful of numeric values defined. Inside of textures.json, we have an array of dictionaries, each one representing a different texture path and key. What this allows us to do is to instantiate a ton of different values that our game engine might be using at runtime, rather than requiring them to be compiled in every time we change something. This ends up being incredibly useful to our development process because, like, for example, one thing that we're now able to fine tune is the size of the blood pixels. Over in the textures.json file, I'm able to specify the width and the height of each blood pixel that we spawn. Setting these to different values, we can immediately run the game and observe the effect. If we set the width and height to 2, the pixels look small and clean and produce a nice look. If we set the width and height to 32, the pixels are gigantic and unconventional. But we can also change the color as well. We can create a world of white blood pixels that might complement our soul shards nicely. We can create a unique blood pixel of blue color as well as green or any other RGB that we define. What about the number of blood pixels per kill? Well, that's defined over in game.json. We can now tune how many pixels of blood we generate whenever an enemy is killed using this value. However, we have to be careful. Setting this value too high can result in significant game slowdown. So let's take a look at what both a small and a large value can produce. Now, something really interesting is happening at 4x4 blood pixels with 1,000 units each. The first kill goes fine, and things render seemingly normally. But at a certain point, things slow down really bad. There was a little bit of a glitch with the first couple records, and I actually managed to catch a bug occurring where the game starts to lag incredibly bad. And I'm not sure exactly what it is because I'm pretty used to being able to render thousands of things onto the screen all at once, like we're doing here, and not experience much of a slowdown. It only ends up being at a certain number of entities when we begin to start choking on the CPU a bit. But this particular record thing seemed to be working out pretty nicely. But just for viewer entertainment purposes, I will attach the video showcasing the bug that I discovered on a couple previous records while trying to capture 1,000 blood pixels per kill. Enjoy.